In this class, we're going to take a look at how you factorise a trinomial. So a trinomial is a type of algebraic expression which has got three terms. So tri means three. So it's got three terms, but also it's got the descending powers of the variable. So an x squared term, then an x term, and then a number term. So these are all different types of trinomial, but you can see they've all got the same format. So when we factorise a trinomial, we factorise it into two brackets. So what we're looking to learn in this class is how do we take this expression and write it into two brackets. When we're factorising in general, we're putting things into brackets, but we're kind of thinking backwards of expanding the bracket. So what do I mean by that? Well, once we put this trinomial into brackets, if we then expand out those brackets by multiplying them out, we should get back to where we started. So when we're putting things into brackets, we're kind of doing that multiplying out, expanding brackets in reverse in our heads anyway. So let's maybe start by thinking about what happens when you multiply out brackets, and then we'll use this information to help us factorise these. Trinomials are super important. They come up in a whole bunch of courses and techniques. Factorising a trinomial is something you're going to see a lot probably in the future. So you want to get to the point where you can do these quite comfortably, but they do take some practice. So expect to get a little muddled at first if you've never seen these before. The format changes a lot. So you could have different combinations of plus and minus, different types of number on the end. If you've got a number in front of the x squared, that makes it more difficult. So there's a few different levels to kind of work through. Okay, so let's just take a step back and think about multiplying out two brackets. So when we do this, we have to multiply everything in the first bracket to everything in the second. We can illustrate that by saying like x will multiply to the x will multiply to the 1, 2 multiplies to the x, and 2 multiplies to the 1. So we're just using that as kind of a visual to remind us how we multiply the brackets. You might have an acronym for that, like FOIL or something like that, that helps you to remember like first and last and middle and that sort of way of doing it. But essentially, it's just these red lines multiplying everything together. So x times x would give you x squared. So we'll try and do these in descending powers of x. That's the way you want to do it. X times 1 gives you 1x. 2 times x gives you 2x. So we've gathered our x's in the middle. And then 2 times 1 gives you 2. But when you multiply out these two brackets, you always get 4 terms. The middle two, the x terms, will combine. So when they combine, you get 3x, in this case, plus 2. That is now a trinomial. So notice what happened there. We started off with two brackets. We made it into this expression with 4 terms, but the middle two terms combined to give us a simplified term. So that is always going to happen, okay? So it's important to note that for when we come to go backwards, because we're going to have to think about what happened here, but going from here back to here, kind of missing out this middle step actually. So it's not easy going this way back to this way, but let's kind of work our way through it. So notice that the 2 here, the 2 was just the product of 1 times 2, because the only way you can make the number term is by multiplying these numbers together. The only way you can make the x squared term is by multiplying the x's together. So that kind of tells us that if we started here, we know that our x squared term is going to come from x times x. We know that our 2 is going to be 2 times 1, because those are the only two factors of 2. If this was some other number like 20, it could be 10 times 2 or 5 times 4. We'll chat about that more later. So it's really the middle term which is the key kind of these. You've got to consider the combination that's going to give you the middle term. Good way to think about it is that the two numbers you put in the end part of your bracket, they've got to times together to make this number, and they've got to combine together like we did here to make this middle number. So switching it over here, to make an x squared, the only way we can make an x squared is by an x and an x. To make a 12, by whatever number goes here and here, it could be a 12 and a 1, it could be a 4 and a 3, or it could be a 6 and a 2, but the key is that the combination needs to give us 8. So 12 and 1 isn't going to work, 4 and 3 isn't going to work, because 4 plus 3 would be 7x, so we need to go this time for a 6 and a 2. This question has two plus signs here, so we're going to go for a plus and a plus, and that's us done. And we could check that by multiplying it out, because x times x would give you x squared, x times 2 gives you 2x, 6 times x gives you 6x, 6x plus 2x gives you the 8x, 6 times 2 gives you the 12. So that's basically the process we go through for these. And these two guys are equal, remember. This is just the factorized form of that trinomial. So applying that to this guy, a little bit more difficult with the negatives. As you move through different levels of these, you'll see added complications with plus and minus and different types of number. So we can go straight into our x and our x, because we know we'll need that to make the x squared. 15, there's not as many factors of 15. You could have 15 and 1. It's hardly ever the number in 1. Sometimes it will be, but generally it's two smaller numbers or two middle numbers. Instead of the extreme 15 and 1, it'll be two numbers somewhere in the middle. 5 and 3 makes 15. Question we've got to ask is, can you use a 5 and a 3 to combine them to make a minus 2? So let's actually just stick in the numbers, 5 and 3, and kind of work that up. So x times x gives you x squared, 5 times 3 gives you 15. We can deal with the sign in a moment. Can you theoretically use a 5 and a 3 to make a minus 2? You could, if you had a minus 5 and a plus 3, because minus 5x plus 3x would give you minus 2x, minus 5 times plus 3 would give you minus 15. So we'll actually just quickly check this one. Let me write it in red. Just working the brackets out, multiplying them out to see what we get. X times x gives us x squared, x times 3 gives us 3x, minus 5 times x gives us minus 5x, minus 5 times 3 gives us minus 15. If we then combine these two guys together, we're going to get a minus 2x, so x squared minus 2x minus 15. So we've run through that kind of self-check. We've got what we started with, so that is the correct factorization. Not easy, takes a bit of practice and a bit of experience. Let's have a look at this example here. So again, we can just set down our two brackets. We know it's a trinomial. Not all trinomials factorize, by the way. Like if this number was, I don't know, 11 or 13, maybe some prime number like that, or just some other number, it wouldn't factorize. The ones that do factorize are obviously the ones you're going to get in a question, or else you wouldn't be getting that question. So let's go ahead with this one. So we're going to need an x and an x. The factors of 8 are 4 and 2 or 8 and 1. You can't make a 6 with an 8 and a 1, so it has to be a 4 and a 2. So stick in your 4 and your 2. Just got to think then about the signs. So we need to make a plus 8, so it could be plus plus, but it could also be minus minus, because minus 4 times minus 2 also gives you a positive 8. We need to make a negative 6, so there's no way you can make a negative 6 with two positive numbers, so that tells us we have to have a minus 4 and a minus 2. X times x gives you x squared, minus 4 times minus 2 gives you 8, minus 4x minus another 2x would give you negative 6x. A little bit more difficult, that one, when you've got to create a double negative, but fairly common. You'll see that quite a lot in these questions. This is the most difficult one. When you've got a number in front of the x squared, it raises the bar up to like a new level of difficulty. So it's a fairly similar process, but it requires a bit more thought to get the numbers correct. So to make a 2x squared, we would need a 2x and an x. So you can start by putting that into your bracket. To make a 3, at least with a 3, it's a prime number, so it has to be a 3 and a 1. The question is it 3, 1 or is it 1, 3? Doesn't matter in terms of making the 3, because if you put a 3 and a 1 or a 1 and a 3, both of those times together to give you a 3, but we've got to consider the combination in the middle, these middle terms, to make the plus 7. To be honest, this just takes a little bit of experience. What you've got to remember is that the numbers combining to make the x term in the middle come from whatever number you put here times into the x, and whatever number you put here times into the 2x. The difference with this one is whatever number you put here, it's not just multiplying to an x like it was in these, it's multiplying to a 2x. So effectively it's getting doubled. So sometimes with these you've just got to go with trial and error. We know it's either 1, 3 or 3, 1. So let's maybe try 3 and 1. And we'll put in a plus and a plus to see how we're getting on with that. So just checking that. So 2x times x gives us 2x squared, that's fine. So check. 3 times 1 gives us 3, perfect. These two would combine to give you a 3x, so I'll just write that down, 3x. These two would multiply to give you a 2x, so it's going to be 3x plus 2x. 3x plus 2x is 5x, and we wanted a 7x, so we've not been able to achieve that middle term. That tells us that that's not correct. The only other option to make a 3 would be the other way, so a 1 here and a 3 here, so let's check that one. So 2x times x is still 2x squared, that's fine. 1 times 3 is still 3, that's fine. These two make a 1x, so 1x. These two this time though combine by multiplying to make a 6x. So if we then add those together, we do get a 7x. So you can see those ones require a bit more thought, but more than anything, they just require a bit more experience. They're definitely a level or two above these ones here. Once you've mastered these ones, which won't take you that long, then you can move on to these ones. They do require that little bit of extra practice and experience. So that's how you factorize trinomials into two brackets. It's a core skill. Like I said earlier, it comes up in a whole bunch of techniques. It's a good one to pay particular attention to. And once you're ready, move on to these guys and try a few more challenging questions that look a little like this. So definitely spend some time working some practice questions on this topic.